Hi guys, good evening everyone. Good evening guys. How are you all? I hope everyone is doing well. So what we'll be doing today is we'll be discussing a very important topic, that is how to calculate hybridization of any given compound. Hi Akshay, good evening. So we'll be discussing about how to get to know about hybridization of any given compound. We won't be studying any theory part, how we got hybridization, everything and all. No. We'll be strictly talking about the business, like the type of questions that you get in the exam. So you get about what is the hybridization of the given compound, right? So they ask straightforward about the hybridization in whatever exam you are targeting for. So this question is for sure asked. So we'll be discussing, yes, so we'll be using formula and also how to draw the shapes and from structure also. So from the structure as well as formula, both will be learning how you can get to know about the hybridization. Okay, and also guys, I'll be telling you about the formula. Many of the students, they just learn from the textbook that okay, this is the formula. From a few reference books they give that formula, but it doesn't give that this formula is not applicable for few things, and because of that you can do many of the mistakes, right? So that formula we have, we'll be learning that the formula to calculate hybridization, but also that this formula is not applicable for which and all things, and if it is not applicable, how you will be finding it out by the given structure or by making the structure. So that's what we'll be knowing. Okay, so before starting with the topic, guys, all those who are new learner on the platform, let me just quickly introduce myself for them. So, hi guys, I'm Manisha Rani, your chemistry educator at Unacademy, and I have enriched experience of online and offline teaching at reputed institute for more than 5 years. I have completed my masters from NIT Warangal and bachelor's in chemistry from Delhi University. I have cracked many repeated exams like IIT JEM, CSA, NET, and GATE, and I have given best ranks through my students, and I am a plus verified tutor, guys. So, yes, without wasting the time, let's just start with the hybridization. You all must be knowing that hybridization is nothing but it is the intermixing of orbitals to give a set of new orbitals. Yes, which are similar in shape, size, and energy. Very good. Absolutely, Akshay. So that we know the definition. Okay, how we got to know about concept and all that we have learned like many times. But let's just discuss how to get to know the hybridization of anything. So very important if I talk about with the help of structure. So what you can do is, if I say how you can calculate hybridization, one, you can do it with the help of structure. Another, you can do with the help of a formula, which I'll be telling. Okay, so if you want to calculate with the help of structure or formula, both the things, one very important thing is required, which is nothing but a steric number. What is required, guys? Steric number. You have to always calculate first the steric number. Now, what is steric number? Yes, steric number is nothing but, okay, so hybridization, whenever you want to calculate, I'm just repeating it again. You have to, yes, whether you want to calculate from structure or from formula, you require a steric number. Now, what is steric number? Steric number is nothing but the number of lone pairs and bond pairs in a compound. What is that? Number of lone pair plus number of bond pair present in a compound. I hope everyone knows what is the meaning of lone pair and bond pair. Lone pair means, yes, as the name itself is saying, lone, right? So lone pair means the electrons which doesn't participate in the bond formation, while bond pair is the electrons which participate in bond formation. They are considered as bond pair. Very good. So steric number is important for both the things. So let's just discuss first how you'll be finding it out with the help of a structure. And yeah, no, lone pair also participates in hybridization, Akshay. So we'll be discussing that. You have to even consider lone pair for telling the hybridization of any compound. Okay, we'll discuss that. Okay, so related to structure, you can find it out. Like from structure, you can find it out by, yes, Okay. Yeah, correct, Akshay. In bonding, absolutely. So in bonding, are like the lone pair are the electrons. Yes, absolutely. Because you didn't write the electrons, that's why I got confused. So absolutely correct. Lone pair are the electrons which doesn't participate in bonding, while bond pair are the electrons which participate in bonding. Very good. Now let's just discuss about on the basis of steric number. Like if suppose I got to know number of lone pair plus bond pair, so how I'll be able to tell the hybridization? And will I be able to tell the bond angle? So let's just discuss that. Okay, so what will be the hybridization for it? And for the particular steric number, guys, remember there is a fixed geometry and fixed hybridization. Doesn't matter how many lone pair you have, how many bond pair you have, but if you have a particular steric number, you will have a particular hybridization and steric number. So remember that for a particular steric number, hybridization and geometry is fixed. Shape can change, right? Even bond angle can change, but hybridization and geometry is always same. So for particular steric number, hybridization and geometry is fixed. Hybridization and geometry is fixed. This is very important. Always remember. Okay. So we have written that. Now let's just discuss what are the geometry for different steric number quickly so that we can easily tell the answer for hybridization and geometry for every steric number, right? So for a particular steric number, hybridization and geometry is same. So we have written in little less space is always same. Okay, is same. So like what we can relate, same as in for particular steric number and hybridization geometry is fixed. We can also write that like it is fixed and it's not going to change. Okay, whatever is the condition, whatever you have the number of lone pair, it's not going to change. Like for example, if you have a steric number 2, guys, yes, if you have a steric number 2, yeah, it's not serial number, guys, this is steric number, remember that. So if you have a steric number 2 all the together, yes, if you have 2, the hybridization is SP and geometry is linear. Good, Akshay. If you have steric number 3, so hybridization will be SP2 and geometry will be trigonal. Hi, exact comments. If you can tell me your correct name, your exact name, it will be really good. So it is trigonal planar, correct? Very good. And if we talk about the 4 steric number, it is hybridization is sp3 and it is tetrahedral. Good. Steric number is 5. What you can relate, the hybridization is sp3d and it is trigonal bipyramidal. The geometry, it is fixed. Okay. For steric number is 6, hybridization is sp3d2 and it is octahedral. Very good. And if steric number is 7, yes, do you know, guys, what is there for steric number 7? Hybridization is sp3d3 and it is pentagonal bipyramidal. Very good, Akshay. So what we can relate, it is pentagonal what? Bipyramidal. Like we have for 5, it is trigonal bipyramidal. For 7, it is pentagonal bipyramidal. So we have to know from steric number, yes, 2 to 7, we have to know all of them. And what will be the hybridization and geometry according to it, that's what we have to know. So let's just discuss that if a structure is given, how we'll be telling it. Okay, so let's just see, everyone, that for methane, for ammonia, and for water, what will be the hybridization? Let's just discuss that. And also what will be the geometry, let's just discuss that. So remember that I have written about geometry, guys, I have not written shape. Shape can vary, but geometry is fixed. Geometry is the arrangement of bonds and lone pair in a space, right? Like how they are going to be arranged, that's a particular particular kind of structure it acquires, right? So that's what we relate. Very good. So what you can relate, good, Akshay. So for all of them, first what we'll be doing, we'll be calculating the steric number. So steric number is equal to number of lone pair plus bond pair. Methane has 0 lone pair plus 4 bond pair. Ammonia has 1 lone pair plus 3 bond pair, and water has 2 lone pair and 2 bond pair. So although the combinations are different, but they all have steric number 4. So because of this reason, guys, all of you should know that they all will have hybridization, which is nothing but, yes, all have hybridization, which is nothing but sp3. And if they all have sp3 hybridization, how we got it? See, first of all, I hope everyone knows how to make the structure of it, right? So you will find it out the central element, like you have find out carbon, nitrogen and oxygen here. Why? Because hydrogen can never be the central element. Why? Because hydrogen can make only one bond, and if you will be keeping that in the center, yes, your other atoms will be in the air. Correct? They won't be bonded. So remember that if hydrogen is there, so the other element obviously is going to be the central element. You will make the valence electron and share to the bonding. You will get the structure. It's so simple. Right? Very good. So here for all of them, the steric number is 4 and geometry is also tetrahedral. Although their shapes are different, bond angles are different, but geometry and hybridization is going to be absolutely same. Now here I'm going to tell you about one more thing also, guys, which is very important, which they asked. So remember, guys, whenever you have to tell geometry, so geometry, what? In that we consider both lone pair and bond pair. Whenever you have to tell geometry, guys, in geometry consider both lone pair as well as bond pair. But as well as bond pair. But if you have to tell the shape, guys, always remember you just have to consider only bond pair. Consider only what? Bond pair. Very good. To tell the shape. Okay, consider only bond pair. So remember that for particular steric number, shape and bond angle can differ. Okay. Why? How you can relate that? Like suppose if you have methane, okay, what you can relate, it has 0 lone pair and 4 bond pair. So there is no lone pair only to consider. So its geometry as well as shape both are tetrahedral. Okay. While for ammonia, guys, everyone, it's very important. For ammonia, geometry is tetrahedral only. For all of them, geometry is tetrahedral. But shape, guys, how you will get to know? Always remember, whenever you have to tell shape, just hide the lone pair. What you will be doing? On your screen, on your notebook, hide the lone pair and check what shape it is acquiring. Like suppose if I'll hide the lone pair, what I'll see, what kind of shape it is acquiring. It is acquiring the shape like trigonal pyramidal. It's a 3 thing. So it's trigonal pyramidal, everyone. So here the shape is going to be what? Shape is going to be trigonal what? Pyramidal, not planar, okay? Akshay, got it? So it will be trigonal pyramidal. And for water, how you will again tell the shape? Hide the lone pair, everyone. Just put the hand on the lone pair and just check, yes, what will be the shape. So you can check that. See how I'll get to know what will be the shape. So you can check. It's just nothing but the bent V shape, yes, and you can also call it as angular shape. Correct, guys? So this information you get it from Vesper. I hope everyone is able to relate, right? Akshay, Veena, everyone. So it's very simple. You just have to know that for particular steric number, the geometry and hybridization is fixed, but bond angle and shape can vary. And how we find it out? We find it out with the help of Vesper theory, the shape. Very good, guys. Good. So that's what we have discussed. So now if let's just discuss, we have to find out the hybridization of different compounds. So suppose if you have to find out the hybridization of XeF2, xenon fluoride, how you will do that? So first you have to draw the structure. How you'll be doing that, guys? You have to select the central element, which, yes, you have to select the central element first, which is having the maximum, yes, which is having the maximum number of valence electron and which is least electronegative. Why maximum number of valence electron? I said because it can make maximum bond then. Correct. So the first thing which you have to check is the element which is the least electronegative. So xenon is the least electronegative. It contains 8 valence electrons. So first always make dummy diagram, guys. Never ever make the absolute correct figure in the one go only, because you will do mistake. First make a dummy diagram, write the central element, write the side atoms, and just combine them. So you know that fluorine to fluorine, they are going to make two bonds, and then we'll be having three lone pairs. So what you got in the xenon fluoride, you have three lone pair and two bond pair. Getting that, guys? Yes. So you have three lone pair and two bond pair. So all together will give me what? 5 steric number. If there is a 5 steric number, what will be the geometry it will acquire, guys? Tell me. It will acquire the trigonal bipyramidal. Correct? Yes or no? And if it will acquire the trigonal bipyramidal geometry, what will be for the steric number 5 hybridization? It is nothing but sp3d. Simple, everyone. Yes. So sp3d is a hybridization, geometry is trigonal bipyramidal, and shape will be what? Can you tell? Very good. What will be the shape? Shape will be linear, because you will just hide the lone pair. Yes. And you will get to know about the shape. You will only check these fluorines for the hybridization, for the shape, not hybridization. For hybridization, you have to check the whole steric number. But for the shape, you just have to tell just have to check the bond pair. So the shape is linear, and also what you can relate here, guys, hybridization is sp3d and geometry is trigonal bipyramidal. It's very simple. Very good. Let me just give you some other compound also, which most of the students, they do mistake in. Suppose you have ClF7, this compound. You have to find out the hybridization. So how you will be doing that, guys? Tell me. ClF7. What will be the hybridization for it? Can you do that? Yes, you have to first make the structure. Make the rough structure only first, right? Chlorine. You just have to tell hybridization. So by just making rough structure also, you can get to know. So steric number is 7. So hybridization is sp3d3. Correct? Yes or no, everyone? So there are 7 chlorine and 7 only fluorine. Like there is 7 fluorine and there is only 1 chlorine. So they are making 7 bonds. So you have total 7 bond pair plus 0 lone pair. So obviously you have the 7 steric number. So hybridization will be sp3d3. Clear? Everyone understood? Yes. Akshay, Veena, Kanika. Exact. Yes, everyone. Very good. So just to make structure, you have to do that. Now I'll be giving you one more compound where many of the students, they face difficulty in. Suppose you have XeOF2. This compound, you have to tell what is the hybridization. How you'll be telling it? Yes. So it's very simple, guys. Again, which one you are going to choose as a central element? The one which is having least electronegativity. So xenon is having. So first you will keep xenon. You will put, it contains 8 valence electron, because it is not required for you to know their atomic number, their atomic mass. It's just, if you know that it belongs to 18th group, you will be knowing that it contains 8 valence electron. Correct? Very good. So what will happen? You will make that. So 2 fluorine will make single bond. There is 1 oxygen. It will make double bond. Correct? And there will be what? There will be 2 lone pairs. I hope everyone is able to relate. Yeah. Okay. So what you have to do in such type of compounds. Okay, Veena, I'll tell that. Very simple. Whenever you get this type of compounds. Yes. What you have to do, first you have to check what is going to be the least electronegative element. So the least electronegative element is xenon. Okay, because the two most electronegative element are fluorine, oxygen, and after that it's nitrogen, right? So out of all these, xenon is the least electronegative, and xenon belongs to 18th group, so it will have 8 valence electrons. Correct? So it will have 8 valence electron. There are 2 fluorine atoms. They will make single bond. Correct? Because they require only 1 electron. There is 1 oxygen. Oxygen wants to make 2 bonds, everyone. It's very simple. Why? Because oxygen atomic number is 8. Yes. So it will have 6 valence electron. It just wants 2 more electrons. So it will make 2 bond only. And they will be left with how much? two lone pairs, correct? So what will be its steric number and what kind of geometry it is going to acquire? Okay, so its steric number, how you will count, let's just check. So you have one bond pair, two bond pair, two lone pair, and here remember guys, this you won't consider as two, this you will consider as only one bond pair. Why? Because this is very important for all of you to know that we doesn't consider multiple double bond or triple bond are considered as single bond pair to calculate hybridization, are considered as single bond pair to calculate hybridization. Okay guys, to calculate hybridization. I hope everyone is clear. So always remember guys that when you have a double bond or triple bond present, they are considered as single bond pair to calculate hybridization. So this double bond you will be considering as one bond pair, 2, 3 and 2 lone pair. So 3 plus 2, steric number is 5, and if 5 steric number, the hybridization is sp3d. Absolutely correct. Very good. Yes, Akshay. So I hope everyone is able to relate that its hybridization is going to be sp3d. Why it is going to be sp3d? Because yes, we got the, from its structure, we have got to know that it has 5 steric numbers, so hybridization is going to be sp3d. So everyone understood? Anyone is having any doubt here? Tell me guys. Very good. So this way you can find it out for any compound. Like suppose if you have SF6, can you find it out what will be the hybridization for it? Last question from the structure. Yes, and then we'll understand one formula which can help you to find it out, the hybridization. Okay. So SF6, what will be the hybridization? Everyone should tell. Very good. Akshay, so hybridization, what it will be? I can relate that sulfur contains 6 valence electron. There are 6 fluorine only. There will be no lone pair. So I can just simply get to know with the dummy diagram, right? So 6 steric number, so it will acquire octahedral geometry, and obviously it will have a sp3d2 hybridization. Very good. So I hope everyone is clear now with the hybridization from the structure, how you will be calculating it. It's very, very simple. Okay, now let's just understand that how we can find it out with the formula. Okay, so it's a shortcut method, but which has some limitations also. We'll be learning about it. Okay, so talking about the formula by which we can find it out, hybridization is nothing but it is steric number Sn is equal to half V plus M. What is that? Half V plus M minus C plus A. This is the shortcut formula. How many of you have heard about this kind of shortcut formula, guys? Yes, tell me. So the shortcut formula, what it is? That it says half V plus M minus C plus A. What is V here? V is the number of valence electron on central element. Very good, Akshay. Number of valence electrons on central element. Then M is the monovalent side atoms. Monovalent side atoms means what, guys? The one which can make only one bond. So monovalent side atoms are the side atoms which can make only one bond. Yes, right, which can make only one bond. Then what is C? C is the charge on cation. If you have any cationic part, like if it is having a positive charge, so you will just subtract that. If there is any negative charge, you will just add. It's a charge on anion. I hope everyone is able to relate with it, guys. It's simple. So the formula is steric number is equal to half V plus M minus C plus A. Okay. So how will be implementing it? Let's just understand that. Yeah. Suppose you have CH4. The same thing that we have calculated. What I'll do? The steric number is equal to half V. Carbon contains how many valence electron? 4. plus hydrogen. Hydrogen makes only one bond, so 4. There is no positive or negative charge, so half into 8. You have got 4, which is sp3. Steric number is 4, so sp3. Correct. We calculated XeF2 by making the structure. So steric number, how you will do that? Half. Yes. What you will do? Half. Then you have the xenon, which is having 8 valence electron. Correct, guys? 8 valence electron. Now 8 plus you are going to add 2. So half into 10, what hybridization you will get? You will get sp3d. You will get sp3d hybridization, because there is 5 and 5 means you can easily relate. I hope everyone is able to relate with it. It's so simple. Correct? Very good. Now if I say the next one, what you can understand here. The next thing, one more example, let's just discuss. Let's see how many of you will be able to tell. Suppose you have to tell CO3 2 minus. Carbonate you have to calculate. So how you will do that? Again simple. The central element is going to be carbon, because less electronegative, which contains 4 valence electron. You will write its configuration. Atomic number is 6 to 4, right? So 4 plus oxygen. So guys, oxygen, they are divalent. Remember that. They make 2 bonds. So oxygen you won't be considering. There is 2 minus charge, so you are going to add it. So half 4 plus 2, you will get half into 6, which is 3. So steric number is 3. It's so simple. Got that, guys? Yes. But this formula is, yes, this formula is not applicable for few things. Okay. Now on what things it is not applicable, let's just quickly discuss about it. Okay. Within 2 minutes, we'll be quickly discuss about it, that this formula is not valid for. Yes. So this formula is not valid for. First, it is called as, it is not valid for Drago compounds. How many of you have heard about these compounds? Yes. Drago's compounds. Is there anyone who has heard about these Drago's compound? Yes. So Drago's compounds are nothing but the compounds in which, yes, your third period or onward elements. Remember that, guys, third period or onward elements or onward element, if attached to less electronegative element, if attached to less electronegative element, right, means except what? Except fluorine, like, or the one which has, what we can relate, less electronegative element means the one which has electronegativity less than 2.5. We can write that. Element having electronegativity less than 2.5. Means hydrogen specifically. So third period or onwards element, if attached to less electronegative element, then the lone pair present doesn't participate in the hybridization. So basically what you can relate is that, then here, if you have a third period or onwards element, it is attached to less electronegative element, then the compound doesn't participate in hybridization. So guys, the answer for that is going to be then no hybridization. Then the compound doesn't participate in hybridization. Let's just understand about it. This is a whole big topic, but because obviously we are learning in a short form, so we are just discuss that what is the meaning of Drago compound in short form. That if you have third period or onwards element, if it is attached to less electronegative element, then the compound doesn't participate in hybridization. And what are the Drago compounds which comes under this, guys? So there are few compounds which comes under it, like you have PH3. Your NH3 hybridization, if you will check, it's sp3. Correct. But PH3, if you will write sp3, it's wrong. Because phosphorus belongs to third period, guys, and it is attached to a less electronegative element, which is hydrogen. Hydrogen has 2.1 electronegativity. So it's hybridization. You won't write sp3, you will write no hybridization. Okay, so this is a little advanced topic. For the competitive exams also, you can utilize it. So PH3, you will write no hybridization. Okay. your ASH3, SBH3, the answer for this will be no hybridization. So which and all are the, yes, which and all are the Drago compounds, guys? Let me just make you note down that. So you have just 6 which you have to remember, which exist in the nature. So PH3, ASH3, SBH3, your H2S, H2SC and H2TE. So these are the 6 Drago compounds, and if any time this comes, because by the formula you will be able to get the hybridization, right? But remember, all these compounds doesn't have the hybridization, like you can't tell the hybridization for these compounds. Okay, simple. So one is this limitation, because if you will calculate for pH3, guys, you can calculate by the formula 5 phosphorus plus 3, 8. For you will write sp3 hybridization then and there only, right? But its answer is no hybridization, which will be wrong. So this formula is not valid for it. Other than that, this formula is not valid for odd electron species. Second, not valid for odd electron species. Means when you have left with a single electron on an atom. So for CH3, you can't calculate by the formula. Okay, very good. Another one, that compounds having transition metals as a compounds having what? Transition metal as a central element. Transition metal as a central element. For that also, guys, it is not going to be applicable. So transition metal as central element. Okay. So the third limitation, what you can relate everyone, that compounds having transition metal as central element, for them also it is not going to be valid. And also, guys, it's very important that this formula do not calculate hybridization for ionic compounds. Guys, hybridization is a concept of covalent compounds. There are many students who tell the hybridization even for ionic compounds also. Do not calculate the hybridization for ionic compounds. Okay. Very good, Akshay, Rajesh, Veena. And the last one more is there, that compounds having more than one central element. So the compounds having more than one central element, for them also it is not valid. Okay, so these are the 5 limitation. All of you must have seen this formula in many of the reference books, but remember that these limitations won't be there over there, right? And by this now you have got the correct idea that for which and all compounds you can calculate the hybridization. So for rest of the compounds, like 95% of the time, you can use this formula and get the hybridization straight away if they have just asked the hybridization related question. Okay, so what we have discussed today, guys, it's very simple. We today discussed about how to calculate hybridization, whether from structure or from formula. I hope all of you understood about it, and now you are feeling much more confident in the hybridization. Yes, Akshay, Rajesh, Veena, Bakka, everyone, yes. So, okay, guys, make sure you're trying many of the questions from this topic, hybridization, and if you get any doubt, you can write in the comment section, and you can let me know in the classes which we have on our Unacademy platform also, guys, because we have some classes which we keep for the students who are facing difficulty in any of the particular topics. So they are called as special classes, and which are there on our Unacademy platform, guys, which are absolutely free for everyone. Okay, so you can join even that also by downloading our Unacademy app. You can also join those classes. Okay, so yes, make sure, guys, you are practicing these questions, and we'll be meeting in the next session then. So thank you all of you, guys. Bye bye. Have a nice day ahead. So thank you, everyone. Bye, guys. Thank you. Thank you, guys. Bye.